Now I will continue the remaining session, remaining models. Let us see the model. The distance between the two places. The distance between the two places they gave as 200 kilometer. 200 kilometer is the distance between the two places. So this is given as 200 kilometer. That is the distance between the two places. The alpha of the metal they gave, alpha of metal equal to 2.5 multiplied with 10 to the power minus 5 per degree Celsius. The total space that must be left between the steel rails to allow for a change of temperature from, see here, the change of temperature they gave as 36 degrees of Fahrenheit to 117 degree of Fahrenheit. But here the value of alpha they gave as in terms of degrees Celsius. This is the very important. So either you can convert the alpha value in terms of degrees of Fahrenheit, or else you have to convert the degree Fahrenheit into degrees Celsius. So what the information they gave, delta F is equal to they gave. That is how much more 117 minus 36. So this is equal to 1 and this is 81, I think. Am I correct? Yes, this is the 81 degrees of Fahrenheit. Now I want to convert the difference in temperature in terms of degrees Celsius. So from thermometry, we have seen the relation delta F by 9 is equal to delta C by 5. So from this delta C is equal to delta F, how much you got? 81 upon 9 multiplied with 5. So this is equal to how much? So 9 9s are, so 9 5s are 45 degrees Celsius. 45 degrees Celsius. Now what do you want to find? The space that must be left between the two steel rails. That means we need to calculate the value of delta L. So what is the formula for delta L? Delta L is equal to L into alpha into delta theta. So L value is 200 kilometer. L value 200 kilometer multiplied with alpha. Alpha value how much more? Alpha value is how much? Alpha value is 2.5 multiplied with the 10 power minus 5 into rising temperature is how much? 45. As alpha is expressed in terms of degree Celsius and this is also degree Celsius, so that you will get the answer. That is also expressed in terms of kilometer. Because the length is in kilometer, the answer is also you will get in terms of kilometers. Okay, ma? This is a very important model. Very important model here. So this is degree Celsius and it is degrees of Fahrenheit. So both the models you should keep in mind. Okay. So now let us see the next problem. Ma? Let us see the next problem. A metal tape gives correct measurement at 15 degrees Celsius. This is the important model. So 15 degrees Celsius means what? It shows the correct reading 15 degrees Celsius. So 15 degrees Celsius is nothing but what? It is the calibrated temperature. So now it is used to measure a distance of 100 meter at 45 degrees Celsius. The error in the measurement, if the coefficient of distribution is given in the measurement, if here, so is coefficient of distribution, coefficient of linear expansion. So what the they ask only the error, not the true value and all. So what is the formula for error? Error in the measurement. So delta error equal to delta L is equal to L equal to L into alpha into delta theta. So they are asking only the error in the measurement. They are asking only the error in the measurement. So that delta L is equal to L into alpha into delta theta. L is what? 100 multiplied with alpha. Alpha is given as 12 into 10 power minus 6 multiplied with delta theta. Delta theta means 45 minus 15, that is 30. So this is equal to nearly 0.003 zeros will be cancelled. So 36 into 10 power minus 3. This is the delta L value. So 36 into 10 power minus 3. Okay. So this is equal to what we can say now. This is equal to, I can say as 36 into 10 power minus 2 into 10 power minus 1. This I can take it as 3.6 into 10 power minus 2. This is all meters. So this I can take it as 3.6 centimeter. So 3.6 centimeter is the error. So option second one is correct. Option second one is correct. Okay. So only error they ask. Only the error they ask. So you can go like this. Next, let us solve one important problem. Let's solve this. First, read the question now. A steel tape is calibrated 20 degrees Celsius. So, what the information they give? The calibrated temperature they give us 20 degrees Celsius. It is used to measure the length of an object in hot summer day when the temperature is 40 degrees Celsius. So, theta measured is equal to how much more? 40 degrees Celsius. If the measured length is, so what the information they give is measured length they give, that is equal to 5 meters. As you know that if theta suffix m, that is measured temperature, is greater than the calibrated temperature, or the which type of the value you are getting out of the true value and measured value. If L suffix T be the true value and L suffix M be the measured value. Out of this LT and LM, which should be greater? Obviously, you know that LT should be greater than LM. LT should be greater than LM. This is the information you know. Already I explained the logic behind this. Why the true value should be greater than the measured value. So based on this concept, we can say the fourth option is 100% wrong. 100% the fourth option is wrong. So while doing this type of the problems, the measured temperature is greater than the calibrated temperature. As you know that true value should be greater than measured value. Why the true value should be greater than measured value means when the operating temperature is greater, the separation between the two readings. If you take a scale like this, the separation between the two divisions that should be increased. When the separation between the two divisions increases, definitely whatever the length that is shown by the scale, that should be lesser than the true value. So the first step what we have to find is we have to find the error in the measurement. So error is equal to what? Delta L. Delta L is equal to what formula? Lm into alpha into delta theta. This is equal to measured length what they give, that is 5 they gave, and alpha value is how much more? Alpha value that they gave as 10 power minus 5. So 10 power minus 5 multiplied with the rising temperature. So 20 to 40. So the rising temperature is 20. So this is 5 into 2, that is 100, multiplied with 10 power minus 3. That is equal to how much more? 10 power minus 3 meter. That equal to 0.001 meter. So true value is equal to measured value plus error we have to take. This is 5 plus 0.001. So the answer will be 5.001 meter. The answer will be 5.001 meter. This is about the calculation part. This model is very important. Here the calibrated temperature is given as 20, but the operating temperature is at 40. So as the separation increases between the two divisions, you are getting the lesser value. If you are getting the lesser value, the true value is equal to measured value plus error in the measurement. Okay, so this is the one of the very important bit everyone has to keep in mind. So now next let us move on to the next model. This is the most important model. Everyone has to keep in mind. 100% of one profit they will do based on this in the weekend. Even in the final examination, the NEET also, at least 4 to 5 times a bit has been asked for till now price. Here, moment of inertia. Whenever the moment of inertia is the term and it is related to coefficient of linear expansion is alpha. Alpha is the coefficient of linear expansion. Then what are the formulae we have to keep in mind? The basic formula for the moment of inertia is what? I is equal to m into k square you can take. So what I can say here, delta I upon I is equal to some 2 into delta k by k. Approximate formula I already said. So delta I by I is equal to 2 into delta k by k, I can take it as alpha into delta theta. So from this delta I is equal to 2 into alpha into I into delta theta. It is the basic formula. So delta I by I, that we call as fractional change in moment of inertia. So change in moment of inertia is equal to 2 into alpha into delta. So this is the these are the two formulae we have to take into the consideration. Now here if you see the question, here the disk is operating, it is rotating about an axis passing through its center and perpendicular to its plane. Then these are all the questions are varied. These are all the questions are. Now if you see the question mark here, if the temperature of a uniform rod is slightly increased by delta theta, its moment of inertia I about a line parallel to itself. If it is parallel to itself, then in this case, the moment of inertia increases by 0. Parallel to itself means its moment of inertia increases by 0. Sir, why it is 0? Those are all the things you can learn in the moment of inertia chart. So what the moment of inertia, what the relation this is? If you take a rod, I'm taking a rod. If I'm taking it is a rod of length L, L is the length of the rod. And if you take the axis of rotation, you take the axis of rotation is like this. If it is the axis of rotation, the axis of rotation is perpendicular to the length of the rod and passing through the center. In that case, we can have these relations. Okay. All right. So this is the one of the very important one. Sometimes they will ask based on the numerical values. Sometimes they will ask directly these form. If they ask what is the percentage increase in moment of inertia, so delta I by I multiplied with the 100. It is the percentage increase in moment of inertia. That is 2 into alpha into delta theta multiplied with the 100. It is the percentage increase in moment of inertia. So based on this, one more question also, there is a possibility of asking the delta is equal to what, ma? I final minus I initial. This is equal to 2 into alpha into delta theta into I, or you can take it as I initial. So here also I should be there because this is here. I should be here. So okay. So if they ask the question IF is equal to II into 1 plus 2 into alpha into delta theta. These two formulae. So totally what are the formulae we have to keep in mind is the first one is delta I. Delta I is equal to what formula? That is 2 into alpha into delta theta into I. This is the first formula. Second formula. The fractional increase in moment of inertia equal to 2 into alpha into delta theta. It is the second formula. Third formula, they will ask a question, what is the final moment of inertia? Final moment of inertia equal to initial moment of inertia into 1 plus 2 into alpha into delta theta. It is the approximate formula. This is the third. This is the third. So first formula is delta I. Second one is fraction. Third formula is this. Fourth formula, they will ask the percentage of increase in moment of inertia. So this is equal to what formula? 2 into alpha into delta theta multiplied with 100. So these are the four formulae. Very important. Very important. Okay. Right. Next. Next schema here. It is application of that problem only. Application of that problem. That model. Application of that model. Now let's see the points. Just next schema. Application. Application to that problem. A metallic solid sphere is rotating about its diameter as axis of rotation. If the temperature is increased by 200, so what they gave the rising temperature they gave as 200 degrees Celsius. The percentage increase in its moment of inertia is, so they are asking percentage of increase in moment of inertia. So delta I by I into 100 is the question they ask. What is the formula? 2 into alpha into delta theta multiplied with the 100. So this is equal to 2 into alpha is how much more? 10 power minus 5 into delta theta. Delta theta means how much right here? 200. That is multiplied with the 100. So percentage they ask. So what we can cancel out here? So 1, 2, 3, 4. So this will be -1. So the answer will be 0. So second option will be the answer to this simple question. If you remember the formula, it is simple. If not, you couldn't be able to solve this. You couldn't be able to solve this problem. Okay. Next. See the next problem. See the next problem. A sphere of coefficient of linear expansion alpha, mass m, and radius r is spinning about an axis through its diameter with an angular velocity omega. If temperature increases, so there is a relation with that. What the relation we have to keep in mind is the first point. If temperature increases, the first point is moment of inertia increases, and second point is angular velocity decreases. Sir, what is angular velocity? What is moment of inertia? Those things you can learn in the name of the chapter, system of particles. System of particles. System of particles. But the angular momentum, you know the linear momentum. Already in the Newton laws of motion, we discussed it. Linear momentum is the product of mass into velocity. In the same way, there is an angular momentum is there. That is nothing but we can say I into omega. This is equal to constant. This is equal to constant. So what we have to keep in mind is when the temperature of a solid increases, its moment of inertia increases and angular velocity decreases. So that only you wrote earlier I2 is equal to, I can take the point, I2 is equal to what you write now? I1 into, that is 1 plus 2 into alpha into delta theta. Is the formula you wrote earlier. In the same way, whenever the temperature of solid increases, if they ask you to find out the angular velocity, what the formula we have to keep in mind is omega 2 is equal to omega 1 by 1 plus alpha into delta theta whole square. This is the formula. It is the exact relation. So directly we can put the options. Sometimes they will give the answer in terms of approximate formula. Approximate formula means we have to use the binomial approximation, binomial theorem we have to use. So that is nothing but omega 1 into. This I can write as 1 plus alpha into delta theta whole power minus 2. Take to this numerator. So this will be equal to omega 1. There is a formula is there. I already said to you earlier also. Approximate formula means 1 plus x whole power n is equal to, I can take it as n into x. Here, if you want to do this, the value of x should be less than 0.1. It is a mandatory condition, not always. It is a mandatory condition we have. So omega 1 into 1 minus 2 into alpha into delta theta. So you may have a question. Sir, how can you say that alpha into delta theta is less than 0.1? Whatever the questions we have seen earlier, you see the alpha is expressed in terms of the order of 10 power minus 6. But the rising temperature may be 20, maybe 30, maybe 100. So that a value of x should be less than 0.1. So that only we can apply the binomial theorem. This is the approximate formula, not exact formula. the approximates are. Suppose in the options, instead of this option, if I put this option omega into 1 minus 2 into alpha into delta theta. If I put this option, which option you have to choose? Can I say both the second and third, both of the options are correct? No, no, you are not supposed to say both of the options are correct. What I have to say, the second option is only the correct. Second option is only the correct. This is option is only the correct because it's the approximate only, not exactly. This is the approximate only. Approximate formula we are not supposed to be considered. Clear? Right. Is it okay, ma? Right. Now let's move on to the next problem. Let's move on to the next problem. Next model, we can say. Next model. See this question. See this question. Two rods of same length. They give the same length and have radii in the ratio 3:4. Their densities are given as 800 and 900 kg per meter cube. Their specific heats are in the ratio 2:1. When same amount of heat is supplied, here the key point is same amount of heat is supplied. Same amount of heat is supplied. So whenever same amount of heat is supplied to two materials whose lengths are in the, if L1 is equal to L2, alpha 1 is equal to alpha 2, the amount of heat supplied in the first case and second case are same, and if the radius of the solids are R1 and R2, in the case of this, if they ask you to find out the relation between the rising temperature linear expansion, we can say the linear expansion delta L. Delta L is directly proportional to 1 by R square. This is the relation, direct relation. It is the direct relation when these conditions are satisfied. If I say the length of the two rods are same, coefficient of these expansions are same, that means both of them are made of same material, and Q1 is equal to Q2, R1 and R2 are their radius. In that case, we can say delta L is directly proportional to 1 by R. But here, their lengths are same only. The radiuses are different. That's okay. In addition to both of them, two more information also they give. They are not made of same material. If they are made of same material, I can take, if they are made of same material, I can take alpha 1 and alpha 2 are same. And S1 is equal to S2, I can say. In generally, the density is also same. But here, in the case of this, they did mention that both are having the same material. Same material. So this, actually there is a formula is there to do this problem that way comes in the calorimetry only. There you can understand. Before that, I will do the one formula. I think you might be know very well that formula also in the earlier classes, lower classes. That is the amount of heat Q is equal to heat supplied. This is the amount of heat supplied or withdrawn. That equal to mass of the body into specific heat of the body multiplied with the rising temperature. This is equal to, how to write the mass? Mass I can take it as volume multiplied with the density. Volume multiplied with the density multiplied with S. SPS means what? That is a specific heat. Specific heat. That multiplied with what? A rising temperature. That is delta theta. So that is delta theta. So these are the this is the formula you have to keep in mind. In detail about this formula, you will have the discussion in the calorimeter. That is third chapter in the heat. So here if you see the Q is constant only because here the heat supplied C1 same amount of it is supplied is Q is constant. If Q is constant, you can eliminate this. It is the constant value. If it is the constant, how to write delta theta? I can write delta theta is directly proportional to 1 by volume. What is the formula for the volume? Volume is equal to rods they give. Generally, rod means it is of cylindrical shape. For the cylindrical shape, L is the length and if R is the radius, then you can say that the volume of the cylinder is equal to area multiplied with the length. Area means this area only we have to consider. So that is pi into R square into E. So delta theta is directly proportional to 1 upon what volume? Volume is nothing but what? Length into R square into what? Density. Into density is 0 and a specific heat is yes. This is the delta theta value. It is the delta theta value. But what the question they are asking? They ask you to find out what the changes in their length they are asking. Changes in the their length they are asking. That means they ask you to find out the delta L value. What is the formula for delta L? Delta L is equal to L into alpha into delta theta. So this is equal to L into alpha into what is delta theta? Delta theta I can write as 1 by L into R square into rho into S. So here what I can cancel out this L and L I can cancel out. So finally what the expression will get, delta L is directly proportional to 1 upon R square into rho S. So final answer is delta L of 1 by delta L of 2 is equal to what I can say R2 by R1. What is the ratio of the lengths? R2 is 4 upon 3. 4 upon 3 means 16 by 9 multiplied with the ratio of the densities. Ratio of the densities means 9 is to 8. So 9 upon 8 multiplied with the ratio of the specific heats. The ratio of the specific heats. Ratio of the specific heats. What is the ratio of the specific heats here? Specific heats are in the ratio 2 is to 3. So it should be 3 by 2. 3 upon 2. So what you can cancel out here? Something I went wrong. Sorry. Here linear expansion also, that also I have to consider, that I missed here. The linear expansion also we have to consider, which I missed here. Into alpha 1 into alpha 2. So this is alpha also I have to consider alpha value. So here I put a mistake, this is alpha. So multiplied with alpha 1 to alpha 2. How much it is? 5 upon 6. So what I can cancel out now? What I can cancel out? So this is 16. This is 8 and 2 I can cancel out. And this also I can cancel out. This is 2 times I can cancel out. The final answer is what? The final answer is 5 upon 2. Which is the exact answer we got exactly the same. This is the important model. So how can we get this formula? It is equal to ml delta theta formula that you might be studied in the lower class, even if we even if we didn't remember properly. In the kilometer chapter, we have the plenty of the discussion based on this amount of heat supplied or amount of heat withdrawn equal to mass of the body, specific heat of the body into a rising temperature or falling temperature. So clear, ma? Right. Now let's see the next problem. Next problem, let's see. This already I said to you earlier. This already I said to you. This is the standard form only. We have to keep in mind. This is the standard form. The coefficient of linear expansion of an inhomogeneous rod changes linearly. It is changes linearly. If it is changing linearly from alpha 1 to alpha 2, from one end to the other end of the rod, the effective coefficient of linear expansion. I already said, if it is a rod, it is a inhomogeneous. So the alpha 1 value at one end is alpha 1, at the other end is alpha 2. Here what the value they said is, this alpha value is changes from alpha 1 to alpha 2. Alpha 1 to alpha 2, they are changing their value. So they ask you to find out the average effective value, effective coefficient of linear expansion. So I already explained you earlier. In the case of this, linearly changes. Linearly changes means whenever there is a change in the alpha value, we have to go for integration method to find out the value. So if you found that the coefficient of linear expansion changes linearly, then the first formula what we have to keep in mind is alpha effective is equal to alpha 1 plus alpha 2 by 2. It is the first formula. Second one, if the length of this rod is L, if length of this rod is L, then they will ask you a question, what is the linear expansion of the rod? So linear expansion of the rod is equal to length of the rod multiplied with alpha effective multiplied with a rising temperature. So this is equal to L multiplied with alpha effective is what? Alpha 1 plus alpha 2 upon 2 multiplied with the delta theta. Delta theta is the rising temperature. So this formula as well as this formula, both are very important. Please keep in mind. Keep it in mind. Definitely it will help you a lot. Okay. Now this is a very important problem. Very important problem. Already in the JBs 3 times this problem they gave. Before going to this, already I said what is bulk modulus. Whenever the bulk modulus technical term is appeared, you can say K is equal to bulk modulus is equal to, that is K is equal to what I said, delta P by minus of delta V by V. Formula only you should remember at this point of time. Later, the mechanical properties of solids, huge topic is there based on the bulk modulus. So from this, I can say delta V by V, that is a fractional decrease in volume, is equal to, I can say, change in pressure upon bulk modulus. It is the form. Now how to get the solution here? So generally what happens is, suppose if it is a liquid, if we are placing an object here, keeping an object here. I'm keeping an object like this. Right. Now I'm keeping an object. Whenever I'm keeping an object, due to the pressure exerted from all the sides, pressure will be exerted from all the sides upon his body. Pressure will be acting. So due to this pressure, what happens is the volume of the body changes. So let us assume that the volume of the body changes. So this is the decrease in volume of the body. It is the decrease in volume of the body. So now the body volume decreases like this. Okay. So there is a decrease in the volume of the body. This is now the volume of the body. So the volume of the body has been decreased. This is the decrease in the volume of the body. This is the decrease in the volume of the body. Is it clear? So now, if I want to bring back its to its original volume, see here, volume back to the value. So there is no any change in the volume. Suppose if there is no any change in the volume, what should I do? I have to supply some amount of heat energy. I have to supply some amount of heat energy to the system externally. So from the externally, what I have to do? I have to supply some amount of heat energy. Whenever we supply the amount of heat energy, what happens to the volume of this volume again increases. The volume again increases. We have to supply the heat energy until the volume increase. Earlier there is a decrease in the volume. Whenever we supply the heat energy, the volume has to be increased. Now we have to supply the heat energy until the fractional change in the volume is given by gamma into delta theta. So by supplying the heat energy, volume increases. By keeping the body inside the liquid, there is a decrease in the volume. Suppose if the volume remains the same, in that case, what we can say, this equation and this equation both are same only. So I can take it as first equation and this I can take it as second equation. So at equilibrium position, that is volume of the body remains same. So what I can say, I can say that gamma into delta theta is equal to what? Delta P by K. So gamma I can take it as P alpha because here the question they gave as in terms of coefficient of linear expansion rate. So 3 into alpha into delta theta is equal to delta P by K. So my question is, I want to find out what should the temperature of the cube be rise. That means I want to find out the value of delta theta. Delta theta is equal to P by 3 into alpha into K. This is the most important model. Already, I think of 2018 JEE main, this question appeared. In the 2018 JEE. That much very simple bit, very easy bit. And this formula, you can have the plenty of the discussion based on this formula in the mechanical properties of solids. Okay, these are all the topics generally they won't discuss in the mechanical properties of solids. So we are dealing here only. There are all the things. See the next model, next model, simple only question. Question is simple question. Let's see the solution for this. An iron tire of diameter 2 meter is to be fitted to a wooden wheel of diameter 2.01 meter. So initially, what the information they gave me? Initially, the diameter. This is the diameter of a wheel. Now we have to this diameter. They gave us how much more? 2 meter. 2 meter is the diameter of this wheel. So the diameter of this wheel they gave us 2 meter only. This is the 2 meter diameter. They gave us 2 meter. Now this diameter of the wheel has to be fitted into a into a wooden wheel of diameter 2.01 meter. So initially this is the volume of the iron type diameter. Now this has to be fitted to this. So what is the diameter of this? They gave the diameter of this they gave as 2.01. It is the iron wheel and it is what is the wooden. Sorry. Oh yes, it is the wooden. It is the wooden. Okay. Now what I have to do? I have to supply some amount of heat energy to this. I have to supply some amount of heat energy to this. When I supply the amount of heat energy to this iron rod, what happens? Gradually, the diameter, the diameter of the rod gradually increases. Like this, it will be increased. So the minimum diameter of the minimum diameter of the wheel required, the minimum diameter of the wheel required, okay, to fit the iron tire onto this wooden wheel is 2.0 meter. That means what initial length is equal to how much? They gave 2 meter, and the final length they gave as how much? That is 2.01, and alpha value they gave as how much? 11.06. And what is the rising temperature? That we don't. What the question they are asking? The temperature to which the system. That means we want to find out the value of theta 2. Theta 1 they gave. How much theta 1 they gave? 20 degrees Celsius. So what the formula we have to go for this? This formula means delta theta is equal to delta L by L into alpha. So this is equal to delta L is equal to how much more? 0.01 by initial length is 2 multiplied with alpha. Alpha is equal to 11 to 10 power minus 6. So delta theta is equal to if I substitute the value delta theta is equal to what? This you can take to the top side, so it will be what now? I can say 100 into 100 by 22. I think I am not wrong. Okay. So this so approximate value I can go for it. So this I can take it as 22. Approximately I can go for it. So it will be like 22 means it should be 5 only. No? 25 I am taking, it should be 5 only. So near value I can take it as 500. Not near value only I am taking. So delta theta means what? Theta 2 minus theta 1. Theta 1 is how much they give? 20. So that is 500 is less than 500 only exactly because 22 is there in the denominator. So pro exact value how much? Exact value means 100 by 22. 100 by 22 if you calculate. 100 by 22. So it is 4.54 it is coming. It is 4.54 exact value is coming. So that it will be what? 454.5 near value. So 454.5. So theta c is equal to 454.5 plus 20. So the final answer we get is 474. That is the option. Okay, ma? This is the one of the important model. No confusion at all. Simple only. Simple only. So let us see the few models and we will close the session for today. If any models are there, that we will discuss tomorrow. Okay, now, right? Now let's move on to the next problem, next concept. This is a very important concept, the density concept. Density concept is very important. As you know that when heat is supplied, when heat supplied, when heat supplied, when heat supplied to a substance, first one is mass of the substance, mass of the solid doesn't change. No change in the mass. Second point, generally volume increases. Generally volume increases. Third one, density decreases. Third one, density decreases. Volume increases. Mass will change. You know the relation also. What is the volume formula? Final volume is equal to V1 into 1 plus gamma into delta theta. Is the volume formula. In the same way, what the formula we have to keep in mind is density d1 is equal to d0 by 1 plus gamma into d, or else what the formula you have to keep in mind is gamma is equal to d1 minus d2 by d2 into d2 minus d2. All these formulas are important. Seventh one, you can say d2 is equal to d1 by 1 plus gamma into d2 minus d1. All these points are very important. And the eighth one. Sometimes they will ask a question. They will ask a question to find out the fractional change in density. They will ask a question, fractional change in density. So what is meant by the term fractional change? Fractional change in the density. They will ask the question. See, already we have seen the technical term. What is meant by the fractional change? Fractional change means what? So to find out the fractional change in density, the first point how to calculate is d2 by d1. First point is d2 by d1. d2 by d1 is equal to here what I said, mass remains constant. So m is equal to what? M is equal to constant. So d is inversely proportional to volume. As I said, volume increases, density decreases. So if I want to write d2 by d1, I can write here as v1 upon v2. So take the subtraction on both sides with the minus 1. So what you will get, d2 minus d1 by d1 is equal to v1 minus v2 by v2. v1 minus v2 by v2. So this is equal to what is the value of v1? v1 only minus of v2 here. Just supply the formula. What you will get, minus v1 minus v1 into gamma into delta theta by v2. v2 is equal to what again? v1 into 1 plus gamma into delta theta. So here what you can cancel out here. So plus v1 minus v1 you can cancel out. So here my v1 and v1 also you can cancel out. So the final formula what you will get is gamma into delta theta upon 1 plus gamma into delta theta. Calculation only. Everything is very easy only. The calculation part we have to keep in mind. The calculation part is very important. Okay. So these are the formulae we have to keep in mind. So the first one, these are the points. So at 0 degrees Celsius, D0 means the density at 0 degrees Celsius. This is the density at 2 degrees Celsius. So from this, what I can say is D naught is greater than D. Okay. So it is the initial density, it is the final density. So what I can say from this is D1 should be greater than D2. If D2 is greater than D1, it is the one of the formula. So this is the formula for gamma is equal to T1 minus D2 by D2 into T2 minus T1. What the formula is said here? That whenever they ask a question based on the fractional change in density, you can take this one only minus of gamma into delta theta upon 1 plus gamma into delta theta. Just to take this value, then you will get the fractional change in. This is the very important one. Okay. Now let's see the next model. Already earlier also I said a clock which gives correct time at 25 degrees Celsius. So a clock gives correct time at 25 degrees Celsius means 25 degrees Celsius means it is what? It is what, ma'am? It is the, so this is the question. A clock gives correct time at 25 degrees Celsius means it is the calibrated temperature. Except this temperature, other than this temperature, if the pendulum is operating, it will show the wrong reading only. Error only it will. Suppose if the operating temperature is less than calibrated temperature, it moves fast because of length decreases, time period decreases, so that it will move fast. If the operating temperature is greater than the calibrated temperature, that length will increase, length of the pendulum increases, time period increases, so that it will move slowly. Okay, already I said the formula. So delta T by T formula, what I said is half into alpha into delta theta is the formula I said. Now see here, how many seconds a day is a day. They are asking the question based on the day. Will it gain? Even if this is not given, this is not given, as the temperature is less than the calibrated temperature, it moves fast. If it moves fast means the temperature gains. So delta T is equal to half into alpha, how much they give? That is 19 multiplied with, so 1, 2, 3, 4, 5 and 6, so 10 power minus 6 multiplied with the delta theta is 25 minus 0, that is 25, multiplied with 86,400 seconds. Why I have to multiply with 86,400 means they are asking the question in a day. In a day they are asking. So per day means 86,400. I have to multiply. So if you see here, how to eliminate the option means don't give the importance to the powers and all, because here none of the option is having the same integer part. One is 20, 15, 52 and 63. So don't give the importance to that. Just what you need is just multiply 19 multiplied with 25 multiplied with 86,400. What the value you are getting, that divisible with the 22. That exactly what the answer you will get is 20.52 seconds. You will get exactly. Suppose in the question, if they ask a question per week, that means what that p value thing is equal to, you have to take it as 7 to 86,400 seconds. per week if they ask, per month they ask, then 30 into 86,400. So this is the very, very, very important model. Very important model. You should keep in mind. Okay, ma'am? All right. So next one, it is the fractional change in density. Already I said the formula earlier also. I said the formula. If you use that formula, no need to go for these are all the things. No need to go for this. Just apply the formula. What the question they're asking? Fractional change in the density. So what the fractional change in the density formula I said earlier? Delta d by d is equal to what I said, minus of gamma into delta theta by 1 plus gamma into delta theta. This proof already I showed earlier how it gets. So this is equal to sub gamma. Gamma is gamma. Here we have to check whether the gamma is given or alpha is given. Here volume expansion they give. So gamma value 46 into 10 power minus 5. I don't try to write this value directly. Before writing this, you have to check what the type of the expansion they give, whether the variable expansion, volume expansion, or the cubical expansion. Based on that, we have. So multiply with the delta theta. Delta theta means rising temperature they give as 30. So 30 upon 1 plus 46 into 10 power minus 5 multiplied with 30. So the nearest value we have to calculate. What does the minus indicate? This minus indicates that the density decreases if the temperature of the solid increases. That only there is symbols for that. Okay. So those problems, you know, for today's class. So the rest of the problems, only 2 to 3 problems are there. Those problems tomorrow we will see. So thank you one and all for watching this video. So the rest of the problems are, I think, 4 to 5 problems are there. This is beyond the day means levels only. These problems tomorrow we will see. So for the neat point of view, what the discussion I carried, those topics enough for us. So these are all beyond the this day means level only.